In this video, we're going to discuss how our derivative can tell us when a function is increasing and decreasing, and how we can use that to find relative extrema. So here I have formal definitions. It's increasing. This just says if we read left to right, that means that one y value is smaller than the next one. So basically, left to right, it's going up. That's increasing. Again, here, if we look left to right, if our one y value is bigger than the next one, then it's going down. So basically here, this is how we can, this is a theorem that helps us use the first derivative test. If our derivative is positive, that means it's increasing. If our derivative is negative, that means it's decreasing. And if our derivative is 0, that means our function is constant at that point. So what we're going to do is we're going to find those values and figure out what intervals it's increasing and decreasing on. So again, if our graph has a positive slope, it's going to be increasing. If our graph has a negative slope, it's going to be decreasing. So we can find intervals on which a function is increasing or decreasing. Then we can use the first derivative test to determine if we have maxes or mins. So again, when our derivative is positive, we're going up. When our derivative is negative, we're going down. Right in the middle, we hit 0. So 0 is going to be where we have any of those critical numbers. And then we know that those are the only places our derivative changes sign. So we can choose one test value in each interval to determine if it's increasing or decreasing. So again, when we make a change from decreasing to increasing, so if we're going down and then all of a sudden we start going up, then right there at C we have a relative minimum. If our derivative changes from positive to negative, meaning it's increasing and then it starts to decrease right there at C, then that means that is a relative maximum. If it doesn't change sign, then it's neither a relative max nor a min. So that may look something like this. We may have a value there when our derivative is 0, but we're increasing before that. We're also increasing after that. So there's neither a relative max nor a min. So for our first example, we're finding intervals. An interval is a beginning and an end. We're using our sign pattern test. So this is our first time we're really seeing that. But again, on our sign pattern test, we want to know when our derivative is positive, when it's negative, maybe it switches back and forth. So we need to know where we make a change. And we make a change from a positive to a negative number right in the middle at 0. So we got to find those values. So we need to, again, our derivative is what tells us if we're increasing or decreasing. So we're going to start out by finding that derivative. So we get 3x squared. If I take this 2 down here and multiply, I'll get 3x. And I just want to know when this guy equals 0 and when it doesn't exist. Again, those critical points will tell me something happens there. So this guy exists everywhere. But if I factor, I see that I'm going to have 2 critical points here. So x will equal 0, and here x will equal positive 1. Those are the important points on my graph. If I make any changes from increasing to decreasing, it has to happen at those 2 points. So this is called our sign pattern test. And right now we're testing for increasing, decreasing. So our first derivative is what tells us that. So we know that we can possibly make a change at these 2 points. Therefore, everything in this interval has to either always be increasing or always decreasing. It'll be the same with this interval, the same with that interval. So we're going to choose test values. So a good test value to the left of 0 might be -1. So I'm just going to plug -1 into my derivative to see if it's positive or negative. So I probably would use this factored form here. And when I plug in -1 here, I'm going to get a -3. And when I plug -1 in for x, I'm going to get a -2. A negative times a negative is a positive. That means my derivative is positive everywhere in this interval. Okay? Now I'm going to choose a test value here in the middle. I'm probably going to choose 1/2. Okay? Again, this is called the sign pattern test. All I really care about is the sign. So I'm still plugging it in here to my derivative. And when I plug in 1/2, I'm going to get a positive number. And 1/2 minus 1 would be negative. And a positive times a negative is a negative. Finally, I'm going to choose 2 for my test value in this interval. And when I plug in 2, I'll get a positive times a positive, and 2 positives make a positive. So now I can use this sign pattern test to answer the question about my intervals. So it wanted to know intervals of increasing, decreasing. Anywhere my derivative is positive, it's increasing. So my function is going to be increasing from negative infinity to 0. And it's also going to be increasing from 1 to infinity, because that's where I have positive slopes. Okay, my function is decreasing everywhere I have a negative slope, and that's going to be this interval here from 0 to 1. So those are open intervals. Open meaning parentheses instead of brackets, where it's increasing and decreasing. So example 2, I'm now going to find my relative extrema. So I can use the sign pattern test to find that. So again, I need those critical points. So 4x cubed minus 16x. I want to know when this equals 0, and this guy exists everywhere. So I'm going to go ahead and factor out a 4x, and I'll be left with x squared minus 4. If I find those values that make this guy true, here I'm going to get x equals 0, and here I'll get plus or minus 2. So those are critical points, and those are places where I might possibly make a change from increasing to decreasing. So I put those on my number line, and I know that these are the only places it can change. So everywhere in this interval, it has to always be increasing or always decreasing. And the same with each one of my other intervals. So now I'm going to choose a test value in each one of these intervals. So out here, I'm going to choose -3. And here I'll probably choose -1. Here I'll choose +1. And here I'll choose +3. And all I care about is the sign. So I probably want to use this factored form because it's going to be easier to just determine the sign. And I'm plugging in -3. So I'm going to get a -12. And then here, when I square a number, I'm going to get 9 minus 4, which is positive. And a negative times a positive is a negative. So it's decreasing everywhere below -2. Now I'm going to plug in -1. I'm going to get a -4. 1 minus 4 will also give me a negative. So I'm going to get a negative times a negative, which is a positive. Now I'm going to plug in +1. I'll get a positive times a negative, which is a negative. And finally, I'm going to plug in 3, which is a positive. And 9 minus 4, again, is positive, so I get a positive. So here it wants me to find extrema, which means find the max and the min. So if I know everywhere before -2, I'm decreasing. And then everywhere in this interval, I'm increasing. Do you see right here at -2, I have created a relative minimum. I don't care how low it is, I just care that it's lower than everything around it. So I have a relative minimum when x equals -2. If I wanted to find the value, I would plug it in and get my ordered pair. Okay. At 0, then, I'm increasing, and then I start decreasing. So I've created a relative maximum. At 0. And then at 2, I make a change now to increasing again. So at 2, I also have a relative minimum. So these are my relative extrema, which again just means peaks and valleys. I don't know which one's highest. I don't know which one's lowest, but I know I have valleys at -2 and +2 and a peak at 0. Okay? And we'll probably stop for this one. We'll do this example in class, so please remind me tomorrow.